So what would a regular Atwood machine, what would the acceleration of a regular Atwood machine be? So let's call this M1 and this guy over here M2. And if you don't know the mass, like how these two masses are related, then it's going to be really hard for you to decide which way this accelerates. But just the way it's drawn, I'm going to assume that this object, this mass is going to go up, and this mass is going to go down. Okay, so this is going to be the positive direction for mass 2, and this is going to be the positive direction for mass 1. So when I draw my free body diagrams, mass 1, since it's accelerating upwards, its upward force will be bigger than its downward force. So here's the force of gravity on 1. The upward force is bigger than the downward force. We get the force of tension. And then mass 2, the downward force is going to be bigger than the upward force. So here we have its force of tension. Remember, these forces of tension are going to be the same. And then we have the force of gravity on 2 pulling downward. The idea about this then is just we're going to sum the forces. There is no x direction, so we're just going to sum the forces in the y direction. And we get the force of tension on 1 going positive, and then we get the force of gravity 1. So this is M1A is the force of tension minus the force of gravity on 1. When we sum the forces on mass 2, down is positive, and so we get the sum of the forces in the y direction is going to be the force of gravity on 2, positive, minus the force of tension. This gives us the mass 2 times acceleration, which equals force of gravity on 2 minus the force of tension. And I can go ahead and substitute M2G here, and then M1G for the force of gravity on 1. Now at this point, we have a system of equations where these are my two equations. If the idea is to solve for acceleration, we can't set these equal to each other. You might think like, oh, we can set these equal to each other and find the tension. You can't do that because this mass here is different than this mass here. So solving for the force of tension is a great first step. I'm going to do it on this first mass just because if I pull this over to this side, it's going to be positive. So I get M1G plus M1A equals the force of tension. And I'm going to shove that in right here. Mass of the 2 times the acceleration is the mass of the second object times the gravitational field strength minus, open parentheses, the first mass times gravity plus the first mass times acceleration. All right, this is becoming to be a bit of a mess, but all it is from here on out is just a bunch of math. And so I'm going to pull everything with an A to one side and everything with an M to the other side. So I get M2G minus M1G. This is going to become a negative, right? You can pull this negative through. So this negative, when it moves over here, is going to be positive. So M2A plus M1A. All right, pull the A out. So I end up with the sum of the masses times acceleration is G times the difference of the masses. And then that means the acceleration is just the gravitational field strength times the difference of the masses over the sum of the masses. Okay. So I know you're wondering to yourself, what happens if M2, like I assumed up here M2 was greater than M1, and that's going to send it going in this way. Now, what happens if M1 is greater than M2? Well, if M1 is bigger than M2, then this becomes negative, right? This right here becomes negative, and then you'll have a negative acceleration, meaning when I look up here, if this direction is positive, if M1 is bigger, then you'll have a negative acceleration. This will go down. This left side will travel downwards instead, which makes sense, obviously, because the heavier block will fall and the lighter one will rise. Okay, so this is finding the acceleration using a system of equations.